We can use trigonometric functions to solve for unknown sides of right triangles. In this example, we have a right triangle with a 30-degree angle, an unknown base of x, an unknown height of y, and a hypotenuse of 15. First, we're going to solve for x. We know that the cosine of 30 degrees equals the adjacent side x over the hypotenuse 15. If we solve for x, we get 15 times the cosine of 30 degrees. Since the cosine of 30 degrees equals the square root of 3 over 2, and multiplying that by 15, we get 15 times the square root of 3 over 2. Now we'll solve for y. We know that the sine of 30 degrees equals the opposite side, y, over the hypotenuse 15. Solving for y, we get y equals 15 times the sine of 30 degrees. Since the sine of 30 degrees equals 1/2, and if we multiply that by 15, we get 15 halves. Now go ahead and pause your video and try this problem on your own. Here we can use the trigonometric functions cosine and sine to solve for the unknown sides x and y. Let's first solve for the base x. The cosine of 60 degrees equals the adjacent side x over the hypotenuse 16. In solving for x, we get x equals 16 times the cosine of 60 degrees, which equals 16, and the cosine of 60 degrees equals 1/2. 16 times 1/2 equals 8. So x equals 8. Now we can solve for y. The sine of 60 degrees equals the opposite side, y, over the hypotenuse 16. In solving for y, we get y equals 16 times the sine of 60 degrees, which equals 16 times the sine of 60 degrees, which equals the square root of 3 over 2. So we get 16 times the square root of 3 over 2, which reduces to 8 times the square root of 3.